Are we good?
You're live.
All right. Hi, everybody. This is Kevin at solo.io here for our 11th Hoot, which is a live webinar that we do and answer live Q&A, and we unbox some cool technology in the networking space. This is our 4th episode in the API Gateway series. Today, we'll be unboxing Contour by VMware. If you are still catching up, I would highly recommend you watch some of the earlier ones in this series. We've already unboxed Ambassador, Kong, and Traffic. And next week we have Gloo, which is a solo thing, but we will be doing that. We will not be doing that. We'll be bringing on a guest outside of solo to do the unboxing of Gloo. So today we're here to unbox and take a look at Contour. So I think a good place to start here would be their website. So backing up, Kong is an Ingress or an API gateway for those who may not be familiar. An API gateway is a management tool that sits between a client and a collection of backed services. An API gateway acts as a reverse proxy to accept connections for API calls and routing them and setting to a set of rules and returning appropriate results. So it's a tool that teams use to decouple their applications and application development from their outward-facing APIs, and it helps businesses scale. So let's take a look here at Contour. First, it's a high-performance Ingress controller and API gateway for Kubernetes. It's built to Kubernetes first. It's built on top of Envoy. So Envoy configurations, that means it gets dynamic reconfiguration through Envoy's XDS protocol. This is fantastic because it means that you can update your Envoy, your proxy, or your reverse proxy configuration without restarting your proxy. Continuing on, so Envoy, flexible architecture. So you can do Contour can be installed as either a deployment or daemon set. I believe in the demos they install both, and they also handle TLS certificate delegation. And delegation, it appears to be a large part of Contour in general. They're very big on allowing teams to work separate from like cluster admins who handle the admin level Contour config, and then teams being able to handle specific configuration of certain parts of their API gateway. So another Contour is an open source API or Ingress and API gateway built by VMware, built on Envoy Proxy. Here's their GitHub repo. Taking a look. So where did I want to take us? So let's just take a look at some of the installation. I think it'd be helpful to start with an example and some of the high level like concepts, I guess is what I'm going for. So let's take a look at the getting started. So first, let's just install Contour to Minikube, which I have open here, already set up. This is an empty, plain Minikube. There's nothing already on here. Just listing all the namespaces. I just spun this up. So here we can install Contour. And let's take a look real quickly at what it installed here. So a couple of namespaces and service accounts. So the custom CRDs that got installed are here. They have Ingress routes, HTTP proxies, and this thing called TLS certificate delegations. So HTTP proxies is their object, their custom resource that handles configuration of the Envoy proxy. It's the newer version that replaces this deprecated Ingress routes. So HTTP proxies is new, but in a beta, and this is deprecated and to be removed soon. But you can really think of them as sort of interchangeable for now, or they have the same end goals. And the same thing with these certificate delegations. So we should be able to take a look. It also installed some RBAC stuff for Contour. And then installed, like it said, deployment and daemon set of Contour. And we can also take a look at the pods that got installed here. It's a very nice user experience for a single command to get started with Contour. So we have two contour pods. One is from the deployment and one is from the daemon set. These are acting as the control plane for Envoy, which is our data plane here. And then certgen ran to create certificates if we wanted to run TLS secure routes. So let's make sure that our contour setup is working. So we installed contour, we add it to our cluster. Now we want to add this service. It's at Kuard, Kubernetes up and running. And so here we can just apply this. And it creates the deployment, exposes the service through a Kubernetes service, and then adds a standard Kubernetes ingress. So Contour allows you to use both the standard Kubernetes ingress, but also as HTTP proxy. I think this is a good time to take a step back and explore the different ways of configuring Contour and the motivations behind some of the decisions they made, or begin with a high level. So let's go to the architecture or documentation. So at a high level, it's a Contour ingress controller. Again, it's built on Envoy. Contour is the management server, so it's like the XCS server for Envoy. It provides Envoy configuration on startup and then acts as the management server while Envoy continues to run. And we can look at a diagram of how this would work. You have exposed your load balancer to public internet. It hits Envoy, which has been configured by Contour running in your cluster. This is exposed on the load balancer, and then Envoy handles the routing to your applications. Envoy is a highly performant reverse proxy made by open source by Lyft. It's used heavily in both service mesh and API gateway, so both service to service, both north-south and east-west traffic. And has a multitude of features of which Contour is leveraging and exposing a fair amount of them. And if we want to just talk a little bit about the philosophy of Contour. So I just mentioned the word service mesh before. Contour is not a service mesh, so it doesn't handle east-west traffic in your cluster. It doesn't intend to. It doesn't handle service-to-service communication. It's purely in ingress and egress in and out of your cluster. It's also mostly focused on HTTP. So it has a TCP proxy, but it's very limited and pretty much just used for, I believe, TLS termination. And it's focusing pretty much entirely on proxying for HTTP. HTTP3 or Quick will be supported in the future. So let's see. So another thing that's really big for Contour is user personas. So they do a good job separating the administrator from /operator, the administrator operator of a cluster from people who are the application devs. So they have lots of delegation concepts built into their custom resources that allow certain configuration to only be controlled by cluster admins and the rest to be exposed by the application developers themselves. Other big things, it's opinionated, they have sensible defaults. Sensible defaults is always nice. Limited feature scope, so they don't intend to do or expose everything. This is both a blessing and a curse. It's easy to use and get started with Contour, but for, we may or may not hit limitations as you try to run it in production, but we'll see. It's unclear. Let's take a step back. And now I want to run through quickly. So like I said before, the HTTP proxy is their custom resource that replaces ingress route. So before we start applying some of these to our cluster and demonstrating what Contour can do, let's just look at this page and talk about what it is they're aiming to do. So taking a step back, this is the regular ingress object they're talking about here, the Kubernetes ingress. This is standard and built in to Kubernetes as a beta. was built to expose traffic from outside the cluster into the cluster. But like they say here, it doesn't have everything supported in a first-class way. And so to expose a lot of configuration people need in production, it resulted in an explosion of annotations. And so you can see this in like the NGINX Ingress controller that's built into Kubernetes. You have tons and tons of different annotations with very specific values that you really need to run this in any kind of production deployment. And so their goal in solving this is to create another custom resource called this HTTP proxy, previously Ingress route, that exposes a lot of these features, but as first-class, strongly typed configuration rather than on annotations, and exposing that through validation and quick feedback of your configuration, which they summarize here. So like validation. So for example, here is a regular Ingress, regular Kubernetes Ingress object. Because it matches all host headers with foodbasicbar.com and routes to a Kubernetes service 1. And an equivalent in HTTP proxy probably follows, if I remember correctly. Or here. So they have food1, bar.com, bar1.com. So this is the regular Kubernetes Ingress. You can match multiple headers and route to the different services. This is a similar configuration in HTTP proxy. They actually have 2 of them. You can't support multiple hosts in a single HTTP proxy object. We can visit this page more in depth. This page goes on for a long, long time with all the different things you can do in HTTP proxy. But just at high level before we get into the demo would be helpful. So let's see. We had installed Kubernetes up and running. So we were in the process of getting started. We ran Kubernetes up and running. Now we want to send requests. No. That's what I want to do. So here, we deployed Contour. We want to run the deployment guide. So the next thing we're going to need to do is I'm running on Minikube. So I need to run this step here to get my Minikube address and use this top value This is going to be useful later. This is the IP that's exposed to outside the cluster, and I can use this to reach my configured proxy, my load balancer, and then route that into services within the cluster. So now that's the only setup I believe I need for Minikube, so we can skip the stuff on kind here. We've installed Kubernetes up and running. And so now we should be able to monitor the progress of the deployment. We just run through all these steps here. Like they say, so this deployment deployed 3 pods here, 3 instances of the Kubernetes up and running service. They're exposed by this single Kubernetes up and running service. And the ingress, there's a natural Kubernetes ingress matching all hosts that will route to this service. So we should be able to, I believe, just click this and this is exposed. So this is the Minikube IP. This is Kubernetes up and running, and it's giving us all the information about the request I just sent. This is the service that's behind that. And this is going through Envoy. So we've already, run Contour and configured it to route to our service. So now that we've got it set up, we can run through some of their other documented examples and see some of the powerful things we can do with Contour. To do that, I checked out and cloned their repo. They have this examples directory here of some example workloads for HTTP proxy. I made some slight modifications that would make it easier to demonstrate some of the things they're doing. Namely, they use this Kubernetes up and running service a lot, but I changed it out for an echo service so that you can see which service is being hit more clearly. So here we have service 1, service 2, service 3, service 2 in the marketing namespace. So this is, we'll loop back to this when we're looking at how things are routing. And similarly, we have a couple deployments for each Echo service, one in the marketing namespace, and then 3 other ones in the default namespace. So let's start by applying our services. Kubernetes apply the common resources. So what this did is it created our service 1, service 2, service 3, service 2 marketing, and our 4 Echo services. So now let's start with the most basic HTTP proxy. This is their custom HTTP proxy custom resource. So let's just apply this whole directory and then show how we can start using this to route. So this HTTP proxy is replacing, this is the most basic form of their HTTP proxy. It's replacing the Ingress. So they're saying we can route on foobasic.bar.com and it'll match. Hold on a sec. I am hearing myself in the background.
You're good. You're coming in clear over here.
So let's just route to this service. This says, okay, match any request. This is a prefix matcher. So any request that starts with /, which is all of them, will be routed to service 1. So here we're going to curl foo basic bar.com contour IP, and it matches all domains. So here we've hit echo 1, which is exactly what we expected to hit. We can check out the pods that we have here and see we have echo 1, echo 2, echo 3 in default, and then it got routed to the right one because this is selected by service 1. That's the most basic form. So we can take that a step further. This is the same one. It's just got a different virtual host. But here we can do the same thing to service 2. And here we get routed to echo 2. So that's just demonstrating the two different HTTP proxies that are routing to 2 different services. But if this is all that HTTP proxy could do, then it wouldn't be very interesting because this is largely built into the Ingress already. But fortunately, we can leverage a lot of other Envoy's features so that we can do more powerful things. So let's start by looking at, let's remove the HTTP proxies that we have currently and apply the next example. What is it? 03 routes. So this, we just applied the entire directory of HTTP proxies here. Let's start with this one. So we have multibar.com. It's routing to service 1 and service 2. So here it should be doing load balancing between those 2 services, the default load balancing. So here we got echo 2, but if we run this a couple more times, we should eventually, there we go, also see echo 1. You see, notice echo 2, but here echo 1. So we got routed to a different service. But we can take this a step further by handling multiple paths. So here's another example. This is saying that, okay, instead of just matching everything with just a single prefix, we can match based on the prefix, we can choose where to route. So here, this is saying if, like it says, match everything else to service 1, but if it's blog or begins with the prefix blog, then it'll go to service 2. So let's take this host and test this configuration. So like we guessed, it says go to echo 1. But if we go to the blog, then we're going to get echo 2, which is nice. This is powerful. And we can go even further by matching conditions on headers. They have all kinds of different header matchers. So if we take this configuration, I believe it just has a prefix matcher, but let's check. So because the matchers we're matching just on the header, not on the route, we're matching all prefix matchers. So let's say, for example, it should go to service 3. This should be echo 3 if I don't have these other special headers. So we expect this to go to echo 3, which it does. But if I add the header Android, then we should go to service 2. And we do, which is fantastic. So we've shown how we can have multiple upstreams delegated on a single HTTP proxy, multiple paths, multiple headers, and special header matching. Another thing that Contour allows us to do is weight shifting. So this example here is saying, okay, let's match everything, and let's route 90% to service 2 and 10% to service 1. So this is similar to the example before, where we have multiple upstreams, but instead of using our default load balancing, we're just specifically describing how much of each, where it should go. So we just run this to verify. So we expect this to go to service 2 90% of the time. So there's service 1, but as we see, echo 2 is the most common by far, 2. But early on, we did get a 1. So it's clearly doing, here we go. And we're running the weights. And the last 2 examples we have in this unboxing is let's look at some of their delegation, because this is one of Contour's best-selling features. So let's take a second and remove all of those HTTP proxies. And let's apply the ones in inclusion. So across example 4. So let's take a look at what we're going to test here. So what this is saying is we have this includes. Includes is saying, okay, let's take the configuration delegated to another HTTP proxy by this name. So anything matching this prefix matcher, which is everything, should include the configuration from main default, an HTTP proxy by the name main in the namespace default. So that's including this HTTP proxy, which is by name main in namespace default and routes to service 2. But similarly, we have this the same or a similar HTTP proxy with a different virtual host that has the same delegation. It allows us to put main in default and include this service as well. This is powerful for 2 reasons. One, like it says, we can have multiple routes, but 2, well, we'll get to that more so in the next example, but it allows you to not just only decentralize config and have a single source of truth, but it can also let you have special RBAC on different resources. If you can include resources that maybe you don't have control over, which is nice as well. But let's take a second and test this. So we applied inclusion. So to test it out, bar.com, which routed to echo 2 like we expected, but we would expect the same thing if we went to just plain bar.com. Bar.com, but it's only these routes. So if we were to do, missing or something invalid, that wouldn't work. Yeah, missing. I think it's left over from another HTTP proxy. That wouldn't work. So now we can take a look at one of Contour's largest selling features, which is their, they have delegated TLS certificates, but also delegation across namespaces, which is really powerful. So let's take a look at this example. Here we have an HTTP proxy that delegates to another HTTP proxy. Via this includes, but it does so to one outside of its current namespace. So this is in the marketing namespace, whereas this lives in default. So in theory, this could be the marketing team, and users could have permissions to this namespace and not have it to the default namespace, or vice versa. But we can still route to services selected by this proxy. So if we test this, we expect root.bar.com include, if we have blog, to go to service 2, but otherwise we expect it to go to service 1. So let's start without the blog prefix and expect this to go to service 1. Like we expected, we get an echo to service 1. But if we were to include blog, then we should go to the service in echo marketing. So we can look at our pods. This service is the one in the marketing namespace too. So we have our echo services in default. None of these are this marketing pod. We actually have to look at the ones in marketing. Oops. And here we can see the service that was actually routed to. And this is just hitting the surface of what Contour can do. They have lots of other examples and useful features here. Some of the really nice ones are, for example, their TLS. They have some really nice sane defaults, like they said. Like they have automatic redirects from HTTP to HTTPS endpoints. And so if you don't include this permit insecure, it'll reroute insecure routes to secure ones and fail them if it can't. This configuration would allow you to hit the insecure endpoint, but that's showing you the same default. It's like, let's always use the secure. Other things they have are sticky sessions, load balancing health checks, all these things that you would expect from a featured, a fully featured API and Ingress gateway. Or they have most of the things. I mean, they don't want to do everything. Same for TCP and TLS termination and pass-through. For further steps, I would recommend playing around with some of these examples, but I will warn you, as currently committed on master, they don't all work the first time. I had to make some changes to these to even get a handful of these to work. I think these worked initially, and 2 or 3 of these I had to fix. So your mileage may vary, but it's still, most of this configuration is good. So you should definitely play around and try it out. And I think that's all I wanted to do in terms of a demo. I just wanted to end with some of my thoughts on Contour. And after my first time unboxing and playing with it, for the last day or 2 days or so. So the first things is that, I think it's been limited in some ways in some of the configurations and what you can do. But I think this is a good thing. Like they say, they don't want to be a service mesh. They don't want to, I think it's right here in philosophy. So for example, what I mean by that is, so they have nice same defaults for HTTP and HTTPS rewrites. They have a good high availability control plane with leader election, but they don't have other things that you might expect out of a more robust and production ready API gateway, such as XDOF and rate limiting, things that are features in Envoy but just not currently exposed. Other things like they have pretty robust header and path matchers, but they don't have other kinds of transformations or expose Envoy's regex matcher, as far as I can tell. These are things that would be very useful for teams to leverage. This isn't necessarily a bad thing, because I don't think they're trying to be the most fully featured gateway, or at least based on some of the things that I've been seeing here. Limited feature scope is one of their philosophies, and I think it makes the simplicity in getting started easy. And there's a lot of merit to that as well. And that's that's all I had for our contour unboxing this week. Stay tuned for next week where we're bringing on a guest to Solo to do an unboxing of Gloo.